Hello, everybody. Welcome to today's event. My name is Simon Wright, and I am the Director of Programming at Japan House London. Welcome to the second in Japan House London's series of webinars introducing the exciting work of JAXA, the Japan Aerospace Exploration Agency. Today's event is called Space Transportation and Earth Observation Satellites. And today we focus on these exciting cutting-edge activities in the field of JAXA's work. As part of a partnership with the Royal Astronomical Society, today's event is chaired by Professor Martin Barstow, who is Professor of Astrophysics and Space Science at the University of Leicester. For those of you who are joining us, please note that your microphone and webcam will be disabled for the entire duration of the event. You can, however, use the question and answer feature at the bottom of your screen to type in your questions for any of the presenters or the chair. At any time throughout the session, we will collect those questions, and there will be a question and answer session at the end of the event. You can send your question anonymously, or you can choose to send it with your name. We hope to answer as many questions as possible, but please do type your questions as we go along. Please note that the contents of this event will be live streamed on Facebook, YouTube, and LinkedIn, where a recording will be archived later. Hello, Martin. Thank you very much indeed. So today's event is actually brought to you from a number of different locations. Japan House is in London, and shortly I'll be passing over to our chair, who is in Leicester. And then Professor Barstow will introduce the presentations from our two key JAXA team members based in Tsukuba in Ibaraki Prefecture, just north of Tokyo in Japan. They are Associate Senior Engineer Yamashiro Ryoma and Associate Senior Administrator Noda Akiko. Thank you very much, Martin, for joining us. We're very, very happy to have you with us today. Thank you very much. For those of you who don't know Martin, he is Professor of Astrophysics and Space Science at the University of Leicester. He is Director of Strategic Partnerships at Space Park Leicester, Chair of the UK Space Agency Science Programme Advisory Committee, and Chair of the Space Telescope Institute Council. His research focuses on hot white dwarf stars and the interstellar medium, and he has published more than 450 papers. He has been involved in many space missions, including, to name ones we may be familiar with, Voyager, Hubble, and the European Space Agency's astrometry mission, Gaia. He's also a former president of the Royal Astronomical Society. Martin, thank you so much for joining us.
It's a great pleasure, Simon. Thank you for that introduction. I'm very pleased to be here, and I'm looking forward to hearing the two presentations, which sound very exciting. So I'd like to introduce our first speaker straight away. Yamashiro Ryoma is a associate senior engineer at JAXA, which is the agency responsible for operating and producing Japanese launch vehicles. And he's going to give us an introduction to the launch vehicles that are available, those that are currently in operation, such as the H2 and the Epsilon launchers, and also talk about the new ones that are under development and future projects, including the next generation so-called easy-to-use H3 launcher. So over to you, Ryoma.
Thank you for Professor Martin. And good morning, ladies and gentlemen. This is Ryoma Yamashiro from JAXA. I'd like to speak about Japanese space transportation system. I will share my presentation. Okay. I know it is a difficult time in London with the spread of COVID-19, but I hope I could cheer you up with some space topics. Space exploration is not a technology that is directly effective against epidemics, but I believe it is an important technology to deal with other human crises that may come. First, let me introduce myself briefly. I have been involved in rocket research and development at JAXA for almost 20 years. Recently, I also support a rocket startup company, so I think I can provide a wide range of information about rocket activities. My hobby is traveling, and I hope to go to London again after this COVID-19 situation is over. So, in my speech today, I'd like to divide Japanese rockets into three main streams. I will talk first about traditional small solid rockets, then about large liquid rockets, and finally about future rockets. When I say solid rocket here, I mean that the rocket fuel is solid, while liquid rockets mean the fuel is liquid. So the first one is solid rocket. In general, rocket development often begins with the conversion of military missiles. But Japanese rocket development began as purely academic university research. The first of these rockets was a small experimental rocket called the pencil rocket. It was about 20 to 50 centimeter long and was fueled by nitro-based explosives. As you can see in the picture in the middle, at first they were striking straight across, but then they started to strike upwards. In the case of the picture on the right, it was launched to an altitude of about 600 meters. The altitude of space is usually considered to be more than 100 kilometers, so it is not quite enough. But this is the first step Japan has taken into space. Then, as the development of the Kappa series, Lambda series, and Mu series progressed, the rockets became larger and larger. The first rockets were 30 centimeters long, but the Mu 5 rocket pictured here on the far right is now 30 meters long. In 1970, Japan's first satellite Osumi was successfully launched on a Lambda rocket. In the photo below, everyone is celebrating. Perhaps one of the characteristics of Japanese rocket is that the people living near the launch site come together to support the rocket launch. The United Kingdom also successfully launched its first satellite Prospero on a Black Arrow rocket around the same time. I have introduced you to the solid rockets of the past, and we are now operating the latest Epsilon rocket, which carries on these traditions. The Epsilon rocket is launched from the Uchinoura Space Center located in south of Japan. Uchinoura has open sea on its east and south sides, which is suitable for safe launch of rockets. The Epsilon rocket will be assembled and serviced in the building picture here, then rotated outward for launch. Now let's take a look at the launch of Epsilon rocket. It may sound loudly. Please be careful. This is a video of the second launch of the Epsilon rocket in 2016. As I mentioned earlier, this rocket comes out of a rebuilding. At this time, the rocket came out of the building, and we did various inspections, and the actual launch was at night. The launch time depends on the requirement satellite to be launched. On this case, we launched Aerospace, a satellite to measure the Earth's geomagnetic field.
第1弾燃焼終了 First stage water burnout.
So far, solid rockets have mainly launched scientific satellites for astronomy and geology. Recently, to meet new user demands, we have been improving the Epsilon rocket for multiple launch or commercial satellites. Then I will talk about liquid rockets. This system was originally developed by introducing technology from the United States, but since the H2 rocket, it has been produced domestically. There are the H2A rocket, which is currently in operation, and the H2B rocket, which retired last year. The H2A rocket is responsible for launching large satellites like that, both domestically and internationally, and has been successfully launched 51 out of 52 times. The H2B rocket is used to launch the HTV, which will deliver supplies to the International Space Station. And it has successfully operated all 9 times according to that plan. Their fuel is liquid hydrogen and liquid oxygen. Now, let's look at the launch of H2A. This is the 40th launch of the H2A in 2018. This time, it's a daytime launch. First, the liquid rocket engine is ignited. Then the booster rockets on either side. This booster rocket is the same as the first stage of the Epsilon rocket that you saw. So you can see that H2A is a large rocket. And the H3 rocket is currently under development as a successor to the H2A rocket. The H3 has improved manufacturing and operational methods to reduce costs and has a greater launch capacity. Testing of subsystems such as the booster rocket and the nose fairing that encases the satellite has already been completed. Now, preparations are underway for the first launch this year. Finally, I would like to talk about the future rockets. The topics are JAXA's research and development activity and the new rocket startup. Let's start with JAXA's research and development. Since the 1980s, winged spacecraft such as the Space Shuttle have been under study. HOPE is a spacecraft that is launched by launcher rocket and fly back by herself. So far, some flight tests have been carried out with small test bed. Since the 1990s, reusable rockets for vertical takeoff and vertical landing have been studied. Several versions of the system are being tested for practice use. The latest system is incorporate an air-breathing engine like a jet engine The United Kingdom is also focusing on these air-breathing engines for spacecraft. So I think there is a potential for cooperation in the future. And now new rocket startups are springing up all over the world. And also in Japan, there are several rocket startups. One of them, Interstellar Technologies Momo rocket, became the first Japanese private rocket to reach space in 2019. In response to these movements, a new private spaceport is being developed in Japan. Interstellar Technologies is launching rocket from Taiki in the north of Japan. And another company is building a launch site in Kushimoto in the central region. I have heard that this situation is also happening in the United Kingdom. For example, there are new plants in Sutherland and UK. And on a different note, last year, Virgin Orbit, part of the Virgin Group, announced that it would use Oita Airport as its launch pad in Japan. Recently, there has an idea of using spacecraft for ground-to-ground travel. And I think it would be interesting to have a spacecraft take off and land between Japan and the United Kingdom. So I like to say the summary. Japan has two rocket systems, anti-solid rockets and powerful liquid rockets, both of which are making progress. Second, there is a potential for cooperation between Japan and the United Kingdom on new space activities, such as air breather engine and spaceport. Thank you very much for your attention.
Thank you, Ryoma, for a fascinating talk. That's really interesting. I was particularly struck by the parallels between the space programs in Japan and the UK. There are quite a lot of geographical similarities, and our countries are similar sizes. I think our GDP per capita is almost identical. And we both have a long history of development of space programs, starting with sounding rockets and solid rockets like you did. I think there was a bit of divergence, though, when we gave up developing launchers towards the end of the 1960s, and we focused on satellites and telecommunications. But actually, we're coming back, as you pointed out, into the launch vehicle development. We have a number of startups like you have. And of course, we have Virgin Orbit in common, who, as you said, are planning to launch from Newquay. And we also have our Scottish launch sites being developed. Again, they're supported by commercial startups, just like yours are. So I think there's a lot of potential for common areas of development and collaboration. And I look forward to working on some of those with you and your colleagues in the future. So thank you very much for that. So I'd like to introduce our next speaker now, who is Noda Akiko, and she's Associate Senior Administrator at JAXA. And she's going to look at JAXA's major Earth observation satellite program, talk about the satellites that are in operation, as well as those that are under development. And she's going to explain how they contribute to our daily life and to environmental protection. And that's a subject that's very close to my heart, because I think real world applications of how we work in space and the benefits to humanity from putting satellites up into space to observe things like disasters and agriculture are really important to our future. So I'm looking forward to hearing this talk, and I'm going to hand over to Akiko right now. So over to you.
Okay, thank you, Martin. Good morning to all. I'm Akiko Noda, and I'm going to talk about our JAXA's Earth observation activity. So I'll share my slide. Wait. Okay, I think you are now seeing my slide. Yes, let me introduce again. I'm Akiko Noda. I'm working for JAXA's Earth Observation Division as a coordinator between data providers and data users. Actually, I joined JAXA in the 1990s because I was fascinated by the idea of observing the Earth from space. That's exciting. That time was the dawn of Earth observation satellite era, and only a few Earth observation satellites were in operation, such as Landsat, and their main mission was scientific research or technological challenges. Now the situation has significantly changed, and there are countless big or small or private and state-owned Earth observation satellites surrounding our planet, and huge volume of data from those satellites are being used for a variety of purposes, for business operation, environmental monitoring, disaster management, and so on. Today, in my presentation, I'm going to focus on how JAXA's Earth observation activities are contributing to society. Following topics are being covered: global satellite mapping of precipitation, forest early warning system in the tropics, satellite observation for disaster management, greenhouse gas observation, sea ice observation, and agriculture monitoring. These contents are our main programs. However, we have many other initiatives. If you are interested, please visit our JAXA website, which I will show you later. Okay, before talking about the usage of Earth observation data, I will show you JAXA's Earth observation satellite lineup here. Currently, 6 satellites, which name are in green, are in operation. 4 satellites having blue colored names are under development. And this year, H3 rocket that is still have a blue colored name is to be launched by H3 rocket. That will be the next generation rocket Mr. Yamashiro mentioned in his presentation. And finally, those of having yellow names have terminated its lives. Okay, let's start with the first topic. This image is one shot of a global satellite mapping of precipitation, which we call GSMAP. JAXA combines 2 JAXA satellite data with other meteorological satellite data from Japan, USA, and Europe, and offers global precipitation information from our website. You may feel this image is very familiar because you can find global cloud coverage image at the BBC every morning. However, this image is near real-time information of rainfall, different from cloud distribution. So GSMAP provides global precipitation data hourly about 10 kilometer grid at free of charge. This service is in very high demand for meteorological organizations and disaster management agencies in countries where there are not enough number of rain gauges and radars, weather radars to cover its entire territories. So total number of GS map registrants, the users, is over 600 from 136 countries. Many of them are in tropical regions such as Southeast Asia and Pacific Islands. Those countries are facing serious challenges to improve the understanding of precipitation patterns and to assess the impact caused by extreme weather events. Next is about the forest early warning system in the tropics. According to Food and Agriculture Organization, the world's forests are declined by 4.7 million hectares a year since 2010. In order to tackle this challenge, JAXA developed a forest early warning system in 2016 with the Japanese International Aid Agency called JICA. The system is named JJ-FAST, JICA-JAXA Forest Early Warning System in the Tropics. Forest cover changes are monitored by JAXA's radar satellite, Aerospace. Aerospace is a satellite. I'm also belong to the satellite operation team. So the radar sensors onboarded the satellite can observe the Earth's surface penetrating through clouds. This is a very important feature because forests in tropics are covered by cloud during the half-year-long rainy season. Especially JAXA's sensor emit L-band radar, which wavelength is suitable for detecting forest cover. Currently, 77 countries, including South America, Central and Southern Africa, and Southeast Asia are monitored. The figure of the left bottom corner shows changes in yellow and recent changes in red. The update of forest cover change has been released about every 1.5 months. Users can use JJ-FAST from anywhere with access to the internet. JJ-FAST can be effective means of forest management, and JAXA experienced a real incident to prove it in February 2018, when the JJ-FAST team and the Brazilian Institute visited the real site detected deforested for obtaining the ground. JAXA's team and the Brazilian team faced the illegal logging activity when they visited the site, which the JJ-FAST system detected as deforested. So like this kind of global information can be useful only when the information can be operationally used by National Forest Management Institute and law enforcement authorities. This is why the JAXA develops and operates this system with Japanese Aid Institute, who takes the role of mediating local authorities and providing training opportunities to local staff. With regard to disaster management, I will introduce two international initiatives. International Charter on Space and Major Disasters and Sentinel-Asia. The International Charter on Space and Major Disasters is composed of 17 space agencies in the world, including JAXA, ESA, NASA, USGS, etc., and provides satellite images in the event of a natural disaster targeting the entire world. Whereas the Sentinel-Asia is a regional activity, a collaboration of 111 members in the Asia-Pacific region. This is a regional activity, but you may wonder why the number of Sentinel-Asia members is bigger than the International Charter. This is because Sentinel-Asia includes not only agencies in space community, but also academy and disaster reduction community. First, space agency in the region, such as JAXA, Indian Space Research Organization, provides satellite images. Next, universities and research institutes analyze image. And finally, the information is shared with the local disaster management authorities and international organizations to use for disaster management. So Sentinel Asia works as an alliance of data providers, producers of value-added product, and information user in respect of using satellite data for disaster management. This slide shows an example of information produced by these initiatives. Emergency observation were conducted in the wake of heavy rain in southern Japan, and the analyzed image shows some possible landslides and damaged bridges. Fourth is about greenhouse gas observation. I'm very proud to say that Japan is a pioneer in this field because the world's first satellite designed especially for monitoring greenhouse gases was launched by Japan in 2008. The satellite named GOSAT. GOSAT means stand for Greenhouse Gas Observation Satellite. It's that satellite observing the concentration of carbon dioxide and methane from space. Okay, and the advantage of greenhouse gas observation from space is, as you can see in the figure on the left, the observation point on the ground are distributed in a specific places. But however, satellite observation points on the left image, you can see the points is uniformly distributed, and the number of the observation point increases dramatically. So GOSAT-2 is a successor of GOSAT, was launched in 2018 to archive long-term monitoring of greenhouse gases. So more than 12 years of the observation record is the longest in the world. As a result, the long-time observation record from space seems to be essential for assessing the Paris Agreement implementation. The IPCC guideline for national greenhouse gas inventories was refined 2 years ago. Usage of satellite data to improve the accuracy of emissions report from countries was described in the document for the first time. The slide shows global carbon dioxide concentration observed by GOSAT-2 in September 2019. The diagram in the bottom left-hand side shows CO2 concentration changes of different latitudes over a decade. CO2 concentration in higher latitude has increased more rapidly than that in low latitude. As I said in the previous slide, high latitude region is most vulnerable to climate change. JAXA and the National Institute of Polar Research of Japan are collaborating to observing sea ice in the polar region using data from our GCOM-W satellite. Sea ice information provided by JAXA is available in near real time through the Research Institute Arctic Data Archive System. The GCOM-W satellite revealed that the Arctic sea ice extent reached the minimum point in 2020 on 13th September. This annual minimum point was the second smallest in the history of satellite observations. Finally, I'll show you last use case of our satellite data in agriculture. As part of Asia Rice Crop Monitoring Project, JAXA developed a web system called Jasmine to provide agricultural meteorological information to the ministries of agriculture in Southeast Asia countries. Jasmine provides information on soil moisture, solar radiation, surface temperature, and vegetation indices and drought indices, so as to assess crop growth. Rice Growing Outlook report is released monthly using local data and Jasmine information in cooperation with Agricultural Statistical Organization in the region. Food and Agriculture Organization integrates the information with similar international projects in other regions and release Market Monitor monthly report through their agricultural market information system, which called AMIS. Right. So JAXA's Earth observation satellite data and research results are elaborated on the data portal site JAXA for Earth. A lot of data can be used at free of charge and available even for commercial use. JAXA for Earth has an excellent search function. Anyone can visit, view, utilize the analyzed satellite data according to the purpose without complicated processing and analysis. JAXA will continue to improve the convenience of satellite data use by providing these various satellite data to many people around the world in an easy to understand and easy to use format. This is my closing, and Nobel laureate in chemistry, Paul Crutzen, said that the impact of human activities has been so great that from a geological point of view, the Earth has entered a new era, which he named the Anthropocene. Today, humans have enough power to shape our planet. So the economic activity of one country affects another country. This often happened in human history, but recently it's negatively affected social and economic activity of that country through degradation of Earth's environment, such as global warming. So the conventionally, each country measures changes and improvement on a country by country basis, such as NDC, National Determined Contribution under the Paris Agreement, and the SDG indicators of the United Nations. And we try to sum up each country report to know the global situation. This approach may be important, but apart from that, Earth observation from space are becoming more and more reasonable too, as they can observe and record the state of the Earth regularly, globally, with consistency. So I believe Earth observation activity conducted by space agencies, including JAXA, European Space Agencies, and many other space agencies, so are necessary to support society for the future of the Earth. Thank you so much.
Thank you very much, Akiko. That was a great talk. And there's a lot of stuff to think about in that. I think it does highlight the important contributions that countries like ours can make to the space business and to monitoring the planet. We might be smaller than the United States and Russia and China, but we can make some really important contributions. And I know that the UK and Japan have long-standing collaborations in space exploration. We've collaborated on several space missions, including Ginga, Hinode, which studied the sun, and an infrared telescope called Akari. And I look forward to doing some more of that in the future. I think we certainly have common interests in Earth observation. And I know that some of my colleagues in Leicester have made good use of GOSAT data for monitoring carbon dioxide over the past few years. And forest monitoring is something we are similarly interested in. We are trying to develop strategies for detecting fires in forests, which means we have to monitor things more frequently. And I think having a network of sensors provided by different operators like Japan, like the UK, is actually an important part of that. I think Sentinel-Asia that you mentioned is internationally important as part of that overall global monitoring effort. We're closely involved in Sentinel in the UK and in the Copernicus program that handles the data. And I am so pleased to see your policy of making data freely available to anybody, because I think that allows people to really deliver on the science, but also to understand how to exploit that data for the benefit of everybody. And I think you get much better exposure than if it's locked up behind a paywall or something. So I think that is a fantastic advertisement for how you do business. So we're now going to move into our question and answer section. Please feel free to carry on posting questions as we go through that. We'll try and take as many as we can. And the first one that I've had forwarded to me is about the Epsilon rocket. So Elizabeth says, I think the Epsilon rocket was designed to be easier and quicker to launch with a very automated system for checks. Was it possible to make the process as easy as you hoped? Was it hard to automate the work needed to prepare for launch? So I think that's one for Riona.
Yes, I already answered that question, but I like to explain. So now already Epsilon has already had the function to check out herself in the ground, but that is not worked in flight. So I like to enlarge that function to check out herself to in flight also in flight. So that function makes flight safety and mission success. So checkout in flight is one topics in the future, I think.
Okay, so I have a question for Akiko from Rich. So do the launch sites used for launching Earth observation satellites by JAXA limit the orbital paths around the globe? Or how do you maximize land observation if a particular orbit is not optimal?
Let me give time. Let me give time to understand.
Let me just repeat that again, then, because it's quite a long question. So I'll break it up. Actually, I think it's probably easier if I give you, because it's actually a series of questions. So do the launch sites used for launching Earth observation satellites by JAXA limit the orbits that you can actually access around the globe?
I think this question will be Yamashiro-san is more suitable to answer this question because I think the launch site does not have launch site is not so important for the launch of Earth observation satellite. I think the function of rocket is more important. If Yamashiro-san complement my comment, please give the comment.
Yes, in launching Earth observation satellites, we need to launch to north or south side. So the launch site must have the open sea in north side or south side. And Japanese launch site, Tanegashima, has open sea in south side, so it's suitable to launch the Earth observation satellites. And speaking about the United Kingdom, also there is a launch site to have the open sea to north or south side, so it's suitable, I think.
Okay,
okay?
Thanks for that. I have a question also for Akiko from Kinjiro Amano. And he asks, what are the advantages of satellite data compared to airborne data?
I think that's a very good question. And I think there is a very big advantage of using both data, satellite data and the airborne data. But the airborne data is very limited, actually. But the satellite data, there is a huge amount of satellite data. But comparison of data is important to improve the accuracy of the analyzed image. So I think the combination use is important, and the satellite data can observe the Earth regularly with consistency. So that is the advantage of satellite data.
Okay, and then he has just a supplementary question that I think is related. So for JJ Fast, can it see through any types of clouds?
Thank you for the question. Yes, that is a feature of radar satellite. And some radar satellite use very short wavelengths, sometimes contaminated by heavy cloud. But our radar satellite, L-band is a relatively longer wavelength, so penetrates the cloud. So that longer wavelength can penetrate the cloud. So it's very rare to contaminate it by cloud of the L-band image.
Okay, right. Thanks very much for that. So I have a question now for Rama. So are future liquid rockets planning to be reusable in space like the SpaceX launch system?
Yeah. Usable? Do you mean future plan of usable?
Yeah. Are your future
system.
rockets planned to be reusable, I think is the question.
Yes. Now, reusable system is under study or under research and development. So that is not practical use. So in the present, many engineers in JAXA are thinking about how to use this study's result. So yes, they are thinking about that. You say now.
Okay, thank you. So I've got another question for Akiko here, and it's from Tim Davis. So Tim says that one of my interests is biomass, which is built in the UK. It will measure global forest biomass. Are you aware and in touch with ESA on this one? He thinks it's for a 2023 launch.
Yes, I'm aware of the project. But when I hear the biomass, I just imagine of the biomass project. There is another biomass project that is a joint international project between European space agencies and NASA, and JAXA is going to join the project that is producing the biomass map of the globe. So I think the UK is also one of the leading company to detect biomass distribution of using different satellites.
Yes, thank you. I think actually the UK's role in some of these things will be quite important this year because of we're hosting the COP21 conference, and I'm sure we're going to play quite an important role in that. I certainly hope so. So I have a question from Doug Millard on UK collaboration on rockets. So he thanks Ryoma for his talk. He says he's very interested in your suggestion for Japan-UK collaboration. Is JAXA in touch with reaction engines already?
Yes, I know the researcher to cooperate with the reaction engine company, but that is only between that researcher and reaction engine. So I expect the project like to make new engines between JAXA and reaction engines. I expect that organization levels and collaboration. Okay.
Okay, thank you. So I've got a question from Zoe, which might be of interest to both of you. And it's quite an interesting one. I think we're all interested in materials when we're working on space, things that might make life better or easier or more cost effective. And so she asks, are there any new materials you need to make in order to solve specific problems with the satellites or rockets? So I don't know if she runs a company that makes materials. Maybe you can provide her with a wish list.
Yes, we always expect to good material appears, and actually we are try to use CFRP composite material and or GFRP to enlight rocket component. How about satellite, Akiko?
Well, actually, I'm not the top runner of this technology, but yes, the new material is very important, has a key role to develop the new satellite to new function. So I introduced today the application area, but manufacturing is our competence. And we always look for new material that improve the function of the satellite. I cannot give you the exact material name, but at the same time, we have to consider the robustness of the material, because I also support the JAXA and ESA joint mission. We are jointly developing the new satellite, but we are loads of problem to develop the state-of-the-art transmitter. But so we have to, I think the new materials is important, but we have to consider how the robust the technology is, how to prove the robustness. Sorry, I think this might be the answer.
Thanks. Actually, I'd like to just chip in there myself, because I think it's not just about materials, which obviously are very important, but it's also about manufacturing processes. That these are things that we need to pay close attention to. to maybe more robotic assembly of spacecraft and modularization of the system so that they can be assembled more easily. Materials have an important role to play in that, because of course, if you're going to do 3D printing, for example, to create components, then the materials have to be able to be used in that environment. So it's an interesting question. So I have another question about the launches again. This is for Ryoma. So are the new private launch operations in Japan focusing on small satellite launches only, like they are in the UK? What kind of payload mass do you think they will be planning to launch?
Yes, yes. In the present, their target is only small satellite. But in the future, I think they will launch more larger satellite after that. Is it okay?
Okay, thank you. So I'm just looking for some more questions. We've got a few lined up. So I've got one here from Naoki Takamoto, which is an interesting one because it's a problem we all have to cope with. Where's the money coming from? And his question, or her question, is what is the funding trend for JAXA? Are you adequately funded for the future? And is your government support, I guess the implicit question that, is it reliable?
Total budget in JAXA is in trend in increasing, but that detail is changed, so it's difficult to say simply.
So I think yes, our budget for the next year has significantly increased actually, but that is mainly because the Japanese government joined the Gateway program, that is the American lead new program to go to Moon and Mars. And but I feel the climate change, it's become a big wave because President Biden appeared, and one of his pillars is climate change, and digitalization, digital transformation is also the theme of the main theme of the international policies. So I think now we have a good wind.
Yes, I think we're all quietly relieved that Joe Biden has brought the United States back into climate change discussions. It's very welcome. So I'm afraid we're now at our last question. So I'd like to thank everybody for their contribution. Sorry if we didn't get around to asking your question and posing it to our speakers. So the final one is, how does JAXA view the startup companies? Do you see these as competitors in the space market business, or are you looking at future collaboration and partnership with them? And I think an example might be how NASA worked with SpaceX in the United States, I think.
Yes, I think JAXA is not competitors, but cooperator. So I like to cooperate with many startups or old legacy space or university and so on.
Yeah, I think there are many startups using the satellite data, and we try to make a good environment for the startup business, mainly by using the cloud platform and AI.
Okay, thank you very much for that. So I think it's time to hand back to Simon to close proceedings.
Oh, thank you very much indeed, Martin. Thank you very much for sharing that. Thank you to everybody for such an interesting session today. Fascinating. Thank you so much. Thank you to Yamashiro Ryoma and
Thank
to
you.
Noda Akiko, who have both joined us from Tsukuba. Thank you very much indeed. And of course, our chair, Professor Martin Barstow. Thank you very much. Thank you to all of the audience. Everybody who has been watching will receive a feedback questionnaire by email. We do ask that you fill that in. It will enable us to continue making these kinds of events, especially if you've enjoyed it. So thank you very much. If you want to learn more about space, please do look into the online programs of our partners for this series with JAXA. This is the Royal Astronomical Society, and their website includes all the details of the upcoming events. And the next one is on the 16th of March, called Supermassive Black Holes, the Ultimate Galaxy Killers. We will put the link to the website in the chat as you are watching, so you'll be able to access that if you're interested. Thank you so much. Of course, we continue our series with JAXA, the Japan Aerospace Exploration Agency. That will continue this spring. Please do look out on the Japan House website and our social media for further details. Briefly about Japan House, we move to ceramics now. We are looking on the 23rd of February in the second in our series of the ceramics town of Mashiko in Tochigi Prefecture, quite close to Tsukuba, in fact. And we are looking at the new generation of contemporary ceramic arts there. We also have our exhibition, which unfortunately hasn't been able to open just yet because of lockdown here in the UK. We will let you know as soon as we are able to open. That is Making Nuno, Japanese textile innovation from textile designer Sudo Reiko. That will be in Japan House in London. And while you can't visit us physically, please do enjoy our virtual exhibition tour of Architecture for Dogs, which we had to close sadly just before Christmas when we went into the lockdown over Christmas, which we're still in now. Thank you so much to everybody. Thank you very much to Martin, to Ryoma, to Akiko, to our partners in JAXA in Japan. Thank you very much to everybody behind the scenes. And of course, to the Royal Astronomical Society as well for partnering with these events. Thank you so much to everybody who's been watching. Take care, stay safe, everybody in Japan, and look after yourselves. Thank you very much.